So just like exponents have exponent properties, when we get to logarithms, we're going to have logarithmic properties that we're going to use as we go throughout the rest of the unit. So the first one is log base b of 1 equals. Remember, this is asking b to what power gives me 1. And every single time, no matter what the base is, b to the 0 gives me 1. So for example, if I had 5 as my base, and I'm doing log base 5 of 1, it's going to be 0. Because remember, 5 to the 0 is 1. Even natural log of 1, that's again going to be 0 because e to the 0 equals 1. So log base b of 1 always equals 0. Property 2, log base b of b. This is asking b to what power gives me b? Well, b to the first power gives me b. So if I have log base 3 of 3, this equals 1. Because again, 3 to the first equals 3. Or natural log of, remember that's base e, so natural log of e is 1. Because e to the first is e. So two basic properties to start. Log base b of 1 is 0, and log base b of b is 1. We're going to use both of those properties when we graph. Property 3 is what allows me to go ahead and do some of my solving of equations later. Property 3 is log base b of m raised to the x power. So what I remember here is I can go through and take a logarithm and lasso down exponents. So this becomes x times log base b of m. Logarithms allow me to bring exponents down. So I remember it as exponents become coefficients. Exponents become coefficients. It's one of the major properties of logarithms we're going to use. So if I had log base 3 of x squared, I'm allowed to go ahead and lasso that 2 and bring them down, and this becomes 2 times log base 3 of x. Where this is going to be even more useful is if I have something like log base 4 of, let's get rid of that, 4 to the x. I can lasso the x down, and that gives me x times log base 4 of 4. So exponents can come down and become coefficients with logarithms. Property 3. Property 4. If I have log base b of m times n, I have a product inside of a logarithm. That's going to become log base b of m plus log base b of n. I remember this one as multiplication inside equals addition outside. So multiplication on the inside of a logarithm becomes addition when I expand it out. So what this would look like, let's say we have log base 4 of 3x. I can expand it because it's 3 times x into log base 4 of 3 plus log base 4 of x. Another example, if I had log of, let's say, 3x times x plus 1, this is going to become log of, well, it's 3 times x plus 1. There's 3 different quantities being multiplied. So I'm going to have log of 3 plus log of x plus log of x plus 1. All 3 quantities have addition between them. Multiplication becomes addition. This property is going to be more useful when we work backwards from this side over there. Later on, we're going to have multiple log terms that we condense down into a single log term. Property 5 is very similar. It's log of m divided by n. So if before I had multiplication that becomes addition, here I have division that becomes subtraction. And remember, this could be any base. I didn't put a b on the base, so I stick a little b in there, and there's a b. So it's log base b of m minus log base b of n. Division becomes subtraction. So for example, if I had log base 4 of 4 over x, this could become log base 4 of 4 minus log base 4 of x. Now I could keep going with log base 4 of 4 and use another property, but for right now I just want to see this basic property. Another example, if I had natural log of x plus 2 over x minus 3, I would have natural log of x plus 2 minus natural log of x minus 3. Again, division becomes subtraction. I can write that here just so I don't forget. Division becomes subtraction. Now again, this one's going to be much more useful when we work from this side over. We can take two logarithms and condense it down to one, and we will definitely use it that way. Lastly, property 6 is a little bit different. If I have b raised to the log base b of m, that's going to equal m. And this is going to be used later when we solve some equations, but I just want to introduce it now. Essentially, the base and the log base b cancel out. So if I take 4 to the log base 4 of x, it's just going to equal x, because essentially those two cancel out. Or if I take e to the natural log of x minus 4, it's just going to equal x minus 4. All I take is what's called the argument, or the middle of the logarithm. So that's property 6. We're going to use him when we go through and solve equations. So properties 5 and 4 are going to be used to solve equations also. And properties 1 and 2 we're going to use a little bit later on whenever we graph, if I scroll back up to the top. So those are the 6 properties of logarithms that we're going to use throughout our unit on logarithms and exponentials.